All right, so good morning all. Today we're going to look at chapter 4. Okay, I will discuss a few questions with you, not all questions. All right, I will leave some of the easy questions for you to try it yourself. So you got the answer here. If you couldn't get the answer, you ask in the group. Okay, you ask in your Telegram group. So don't just PM to P, because PM to P sometimes I might miss the questions. Okay, and then sometimes I might reply quite late. So if you got any questions, you ask in your group. Okay, you ask in your group. Don't always PM the P, because if you ask in your group, when I answer it, your friends get to see it as well. Okay, not just you yourself learn it. So cuba tanya dalam group. Okay, kita ada group. Okay, so I will discuss a few questions with you. I have already selected a few questions. Okay, maybe half of it, because it is impossible for us to discuss all, I think, 16 questions in 2 hours. Okay, so most probably I'll discuss about 8 questions, and then the remaining 8 you tried it. So any questions you post in the group, if your friends can answer, then that would be the best. Okay, so if no, then just leave it in the groups. I will answer it when I'm free. All right, so try to make the full use of our group. Okay, so let's see. Questions number 2. Questions number 2, calculate the magnitude and the direction. So now it wants you to calculate what? It mentioned 2 things. So this question is being very nice to use. It tells you need the magnitude and also the direction. Sometimes question it won't mention these 2 things. Okay, if the question just mentions calculate the force that balance the 3 forces acted at point A, then what does it mean? If the question just mentioned force, it means you need to calculate the magnitude and direction. Okay, so even if the questions didn't mention magnitude and direction, it just tells you calculate the force, then it means you need to find 2 things. Okay, so that is the things that you need to know, the technique that you need to know in answering questions. So now you're given 3 forces, F1, F2, and F3, and they are not balanced yet. It tells you there's one more force that balances the 3 forces acted at point A. So this is our point A. Okay, as shown in the figure below. So what does it mean? Now, this question, it tells us we actually have 4 forces in order for this diagram to be balanced. So right now it's not balanced. We have one more forces where we don't know its direction, where we don't know its magnitude. What can we do? We don't even know which quadrant it is. It could be first quadrant, second quadrant, third quadrant, or fourth quadrant. We don't have any information about the fourth force. Okay, this is our F number 4. So what are we going to do? Now, the key words in this question is balance. Aha. So when you have something that is balanced, when you have something that is in equilibrium, what does it mean? It means now our summations F is equals to 0. It means this one, it refers to first law. All right, so now we have enough information. What are we going to do? We're going to make a table. Okay, we're going to make a table. And then this is X component. This is Y component. We have 1 force, 2 force, 3 force, and the 4th unknown force. Okay, the 4th unknown force that we don't know its direction, we don't know its magnitude. And then what do we have? We know summations F value. Aha, why? Because of the terms balance. So balance, it gives us the values of this one, okay, of this column. So balance, I highlight it in the blue. So the last column also in blue, okay, because I got information based on that term's balance. So what am I going to do now? So I want to resolve the vector into my table. F1, I have 12 Newton, and it is located at 55 degrees above x-axis. So I have 12 cos 55 degree. And then y, okay, of course, is sine. So F sine 55 degree. For the second force, okay, what do I have? I have 20 Newton, and it's located 30 degree above the x-axis. So I have 20 cos 30 degree. But now if you look at the diagram, this is a second quadrant. Second quadrant means we should have negative x. Okay, first quadrant, positive x, positive y. Second quadrant, negative x, positive y. Third quadrant, negative x, negative y. Fourth quadrant, positive x, negative y. So this is the things that you have to keep reminding yourself. So the second quadrant, F2, I have positive y. Therefore, 20 sine 30 degree. And then F3 is in the third quadrant. So what do I have? I have 30 cos 45 degree. But now it is in the third quadrant. Therefore, we should have a negative sign here. Okay. And then F3 for the y component, 30 sine 45 degree. And again, I'm going to add a negative sign here. Okay, because it's in the third quadrant. So you have to be extra careful with the sign convention. If one of the sign convention is wrong, then most probably you are going to get 0 marks in the question. All right. So this type of questions, usually it worth 5 to 7 marks. So it's very important to get the table right. Okay, if one of the item is wrong, then most probably you are going to get 0 mark, or at most 1 or 2 marks. That is the maximum out of a 5 to 7. Okay, so F4, we don't have any value. So what should we do? So you can write it as just F4x, sorry. So F4x and then F4y without sign convention. Okay, because right now you don't know where is it. You don't know whether it's in the first, second, third, or fourth quadrant. So you cannot include its directions yet. All right, you cannot include the sign conventions yet. So what you can do, you can write it as F4x and F4y. Okay, and then the last one, summations F, just now we say because of the term balance, so we know we need to use first law. So it's a 0 and 0. So this is the table that we're going to use to solve the questions. Now that you have all of the informations needed, okay, so what can you do? So you can then calculate it. So we know summations F is equals to 0. Okay, and let's look at x component. So summations Fx is equals to 0. So what are we going to do next? We're just going to add them up. So 12 cos 55 degree plus negative 20 cos 30 degree. 30 degree, and then plus negative 30 cos 45 degree, and then what else? Plus F4x, and we know it is equals to 0. Okay, plus F4x, and then it is equals to 0. So if you rearrange the equations, you will see that F4x is now equals to 31.6 Newton. So that is the values that we have for the x component. Okay, for the x component. So the second part, what am I going to do? Now I'm going to use summations Fy equals to 0. Okay, so what do I have right now? Okay, so I'm going to add up these 4 values. Okay, 1, 2, 3, 4. So I have a 12 sine A. No, I'm going to write it on here. So 12 sine 55 degree plus 20 sine 30 degree plus negative 30 sine 45 degree plus F4y equals to 0. Okay, plus F4y equals to 0. So from here, you obtain F4y equals to 1.37 Newton. So now that you have F4x and also F4y, so what can you do? You can then calculate its resultant value. Okay, so F4, which is the resultant, it is equals to square root F4x squared plus F4y squared, which is then equals to 31.6 Newton. Okay, 31.6 Newton. And then how about the angles? So now you want to calculate the angles for F4, therefore we are going to use F4x and F4y. So angles equals to tangent -1 and then F4y divided by F4x, which is then equals to 2.48 degree. Now the questions would be, where is it? So to determine where is the vector, you look at F4x and also F4y. So what happens right now is that you have positive x and you also have positive y. Positive x, positive y, it tells you now your fourth vector is in the first quadrant. So first quadrant above, positive, x exists. So that is how you solve it. Okay, above, positive, x exists. Done. So this is a complete solutions. Okay, this is a complete solutions. Now, next questions would be, sometimes students forgot. Okay, they go and expand F4x and F4y. So can you still solve it if you expand it already? So for example, okay, let's say this is equations 1, this is your equations 2. What happens? Sometimes students straight away write, okay, equations 1. Instead of F4x, some students, they give me F4 cos theta equals to 31.6 Newton. And then second equation, sometimes students will write it as F4 sine theta equals to 1.37 Newton. Now, can you solve it if you expand it into cos theta and sine theta? Yes, you can. Okay, in this case, what is going to happen? It will just becomes, you calculate the angle first. So you use 2 divided by 1. What are you going to get? It will become sine theta. Okay, you have F sine theta and then F4 cos theta equals to 1.37 divided by 31.6. So F4 and F4 cancel out. Don't cancel out the theta, okay? Quite often it happens. Students cancel out the theta and then ask me what happens. Why I have just sine over cos now without the angle. No, sine theta is one term, cos theta is one term. You don't cancel out the theta. So sine divided by cos is tangent. So tangent theta equals to 1.37 over 31.6. So theta, you have 2.48 degree. Okay, so basically you obtain the angle first. So where is the angles? Again, you refers to the equations 1 and equations 2. So both of them, they are positive. Then from here, you know that it's the first quadrant. Okay, then after that, you just pick one of them, one of the equations, either equations 1 or equations 2. You sub the value into the equations. From there, you will be able to determine F4. So for example, I sub theta into F4. So now I have F4 cos 2.48 degree equals to 31.6. So rearrange the equations. I'm going to get F4 equals to 31.6 Newton as well. All right. So I show you both method. Okay, it's up to you which one you don't use. Just make sure you at least you understand both of them. Okay, kena faham kedua-dua sebab takut kadangkala Anda kena guna terpaksa ikut pilihan yang diberi. Okay, sometimes maybe the questions will give you one of the angle. Then you have to know how to apply the method in blue color. All right. So now I give you 2 minutes to write it down. Make sure you understand both method. Both method give you full marks in the exam. All right, both method give you full marks in the exam. So I give you 2 minutes to write it down. If you have any questions, if which part of it you don't understand, feel free to ask now. Okay, Haziq, apa soalan? Haziq angkat tangan kan? Jadi ada apa-apa pertanyaan?
Tak ada, madam, tak ada.
Okay. All right, so that is questions number 2. So next, let's see which questions I want to discuss. Okay, so untuk yang masuk lewat Bunia, saya ada beritahu tadi, saya tak akan bincang ke semua 16 soalan because it's quite impossible for us to do in the given time. So what am I going to do? I'm just going to discuss a few questions with you guys. So question number 3, I'll leave it to you. This is a free body diagram. We have already tried it in exercise 1. Now I want to look at questions number 4. Okay, questions number 4. This is quite an interesting question because in these questions, our object is not the box. Okay, the object is not the box. So let's see how to solve these types of questions. All right. The system in figure is in equilibrium. So again, we have the terms in equilibrium. So whenever you have the term that is balanced, that is equilibrium, that is at rest, that is moving with constant velocity, then we use Newton's first law. Summations F equals to 0. So this is the key words in the questions, equilibrium. So the system in figure is in equilibrium with strings at the center exactly horizontal. And then calculate the tensions T1, T2, T3, and also angle theta. Now, this is a questions, okay, a rare questions where object, okay, the boxes, they are not acting as our object. Our origin is actually located at the string. So this is our first origin. This is our second origin. Okay, which means we need 2 free body diagram. So I'm going to call it point A and point B. Okay, so you need a free body diagram at point A first. Let's start from point A. So now point A is acting as our origin. Okay, so at point A, what do I have? I have first the tensions 1. So tension 1 is going to work this direction. Okay, with an angle. Okay, it should be dotted line. And then 35 degree. And then if you look at point A again, point A, okay, we have 2 different strings that is joining at point A. Therefore, I should have a second tension that is going to the right-hand side. And then there's a load that is being hung at point A. Okay, so I'm just going to assume it is W. So I have W1. I'm going to call it W1. So that is my first weight. Okay, that is my first weight. And then the second things, what am I going to do? Okay, what am I going to do next? I want to sketch the second free body diagram at point B. Okay, so these questions, I know the origin is located at point A and point B because that is where they meet each other. That is the junctions of all these forces. Okay, so this is the things that you need to know. Origin, okay, we don't always refer to the object. Sometimes it could happen at the joint, where you join different strings together, where you join different forces together. Okay, so we are looking at the junctions. So junctions B, the point B, I have the first force T3 is going to work this direction with an unknown angle. So this is theta. And then again, I have T2. Okay, so this is my T2. And then, of course, there is another weight that is being hung at it. So I have W2. Okay. So this is a complete free body diagram. So if you notice, okay, I did include angle in my free body diagram, the 35 degree, because it is given in the questions. So that is what you should do in the exam. If question asks you to sketch free body diagram, then you identify, you try to look at the question, see what are the informations given. Okay, if you are just given the magnitude, then you just substitute the magnitude. If you are given the angles, then you need to include the angles. Okay, so sometimes students will ask me, can I write values as a W1 and W2? Well, I would prefer you to write down the symbol first. Then if you want to write the value, you just write here equals to 40 Newton. And then this one equals to 50 Newton. Okay, rather than you just put the values into the free body diagram. Because free body diagram, usually we put symbol. All right, we put symbol for the force. So point A and point B, now I have two free body diagram. And then based on this two free body diagram, what can I do? I know that I should have four equations. Because point A is 2D diagram, point B is also a 2D diagram. Okay, and then what is the other piece of important information? Just now, the question tells us they are all in equilibrium. So both of them, they fulfill Newton's first law, okay, which is summations F equals to 0. So now let us form equations. Okay, so for point A, summations F AX. So I'm just going to look at the X component first. Okay, is equals to, now what happens to the X component? So if you want to resolve the diagram in a free body diagram, make sure you draw with a pencil. Okay, so in my first free body diagram, okay, T2 is lying on the X component, so don't have to resolve it. W1 is lying on the Y component, so you don't have to resolve it. What you have to do, you resolve T1. Okay, so you will have T1Y and T1X. Okay, T1Y and T1X. Second free body diagram, if you resolve T3, then you will have T3Y and also T3X. So after you resolve it, okay, let's see what are you going to do. So the first, along the X component, this is what we have, T1X and T2. Whereas for point B, we have T2 and T3X. So this is the force that we are going to put in our equations. So summations FAX equals to 0. Along the X component, I have T1X and also T2. Okay, and T2 is going to the right, T1X is going to the left. Therefore, I use T2 minus T1X. So T1X is T1 sine 35 degree equals to 0. Okay, the reasons why I use sine, because now my angle is located beside Y component. Okay, so Y component we use cos, X component we use sine. So T2 minus T1 sine 35 degree equals to 0. Right, so that is the first things that we know. So rearrange the equations, we obtain T2 equals to T1 sine 35 degree. So this is the first equation where it comes with two unknowns. Okay, where it comes with two unknowns. Now let's look at the second equations. So now I'm done with X component. What am I going to do? I'm going to solve for the Y component. Okay, so Y component. Summations FAY is now equals to 0. So let's see what are the forces that we have along the Y component. So Y component, I have this one. I have W1. Not nice. Okay, I have what? I have a T1Y and also W1. Okay, I have these two things. So what am I going to do next? I'm going to calculate it. So FAY equals to 0. I have two forces along Y component. So I have T1, not T1 is going up. And then the angle is beside T1Y. So T1Y is equals to T1 cos 35 degree minus 40 because W1 is going down equals to 0. So from here, actually, you can obtain the values for T1 already. So T1 is then equals to 48.83 Newton. Aha, now that you have T1, what can you do? You can then solve. Okay, solve T2. So sub T1 equals to 48.83 Newton into 1. So this is what you should do in the exam. So T2 is then equals to 28 Newton. All right. So now you have the informations for T1, you have the informations for T2. So what next? Okay, next, let us solve T3. Okay, so T3 is slightly complicated compared to T1 and T2. Why? Because you don't have the angles. Okay, because angle is unknown. You have just the theta. So what are we going to do now? Okay, again, we are just going to form two equations first. So summations FBX equals to 0. Along x component, we have two forces with T3x going to the right-hand side. So T3x is equals to T3. Okay, now you want to write it as a T3x also can. You want to expand it also can. It's totally up to you. Okay, so let's say it's T3x. So T3x minus T2 equals to 0. So what we have, now we have the values for T2 already, which is 28 Newton. Therefore, T3x is equals to 28 Newton. T3x is not a final answer yet. This is just a value for the x component. So what are we going to do? We form another equations for the y component. So summations FBY is equals to 0. And then back to the free body diagram. T3y is going up. W2 is going down. So T3y minus 50 is equals to 0. And then we have T3y equals to 50 Newton. Now that you have the x component, and then you have the y component, you can then calculate its resultant. So T3 equals to square root T3x squared plus T3y squared, which is then equals to 57.31 Newton. Okay, and then angles theta is equals to tangent -1, and then T3y, which is here, over T3x. Then you're going to obtain 29.25 degree. Okay, so done. So you don't have to describe the positions. Why? Because the question just asks you to determine the T1, T2, T3, and the values of the angle. Okay, it doesn't ask you to determine the positions of T3. It's asking for the angle. So with or without the description, it doesn't matter. Alright, as long as you have the values of the angle. So untuk soalan ini, dia tak payah sebut above ke, below ke, or where is it. Okay, you just need to answer theta is equals to 29.25 degree because that is what is being asked in our question. Okay, so again, I give you a, okay, like this. Okay, so I give you 2 minutes to write it down. All right, I give you 2 minutes to write it down. So this is a questions where it involves two objects, where your second object will use the answer from the first object. Okay, so for instance, this is 28 Newton. This 28 Newton is coming from object A. So this is how you link two objects together, by looking at the common component in it. So the common components in this two diagram is our T2. Therefore, the values of T2 from point A can be used in point B. Okay, that's why I keep telling you guys, subscript is very important. If you got a subscript correct, then you know which value can be used in both objects. So 2 minutes for you to write it down. If you have any questions, you may ask. Okay, kalau dapat mana-mana yang Anda tak faham, Anda boleh tanya. Okay. So next, so questions number 5 is being very nice to you, gives you a nice diagram already. So these questions, I will leave it to you. I will discuss questions number 6. Okay, so questions number 6. Now you have 3 objects that is joining together. So what are we going to do to solve it? All right. So now let's see. Okay, wait, yeah. Okay, so suppose that F is equals to 1000 Newton, M1 is equals to 3 kg, M2 is equals to 15 kg, and M3 is equals to 30 kg. Now, when you have a case like this, okay, where you can move all 3 objects with just one external force F, so it means this diagram, this setup, we can treat as one object. So in other words, these questions, you can actually sketch 4 free body diagram. So now let's see how to sketch free body diagram for each of them. So the first free body diagram is for M1. Okay, so M1, I have an object. So M1 is an object, therefore it comes with weight. So I have W1, and then it's on a surface, therefore I have an N1. So remember, N and W, both of them, they need the subscript as well, because weight and normal force, it depends on the object. It varies with the object. Okay, now F1, okay, F, this external force is being acted directly on object 1. Therefore, it belongs to our first object only. Okay, because it's in a direct contact with my M1. So I put F in the free body diagram for M1. And then behind M1, I have a tension. Okay, tension 1. Therefore, there's another tension 1 that is going to the right-hand side. Okay, that's going to the right-hand side. All right, so this object is moving with an acceleration. How do I know that object is moving with an acceleration? Because you look at questions 8. Calculate the accelerations of the block system. So in which it means our acceleration is going to the left. So this is the part that you have to take notes. So my acceleration is going to the left-hand side. So I'm going to put it outside the diagram. So I have A going to the left. So let's start the free body diagram for second object. So now I have M2. So what happens in M2? Again, I have a dot. Now M2 come with weight again, W2, and now it's coming with a normal force number 2, so N2. If you look at the diagram, now F has nothing to do with M2 anymore. Why? Because M2 is moving, it's because of the pulling force from tension 1. It has nothing to do with this force anymore. This force is not being acted directly on M2. So you cannot sketch F into a free body diagram for M2. So in M2, the force that we have that is directly in contact with this M2 is my tensions 1. Okay, that is in a direct contact with my second object. And then there's another string behind my M2, therefore I have T2. So again, my acceleration is going to the left. Okay, my acceleration is going to the left. All right, let's sketch a free body diagram for object number 3, M3. So M3, again, come with a weight, W3, come with a normal force, N3. And now if you look at the diagram, there's only one force that has a direct contact with object number 3, which is T2. Therefore, I have a force T2 going to the left-hand side. Okay, going to the left-hand side. So this is my acceleration. So this is if they are not moving together. Now, because all 3 objects, they are moving together, I can actually treat them as one complete object, where I'm going to assume M1 plus M2 plus M3 is now acting as just one object, right? So basically, what do I have right now? So if now I treat it as one object, basically this is the diagram that I have. So this is a very huge object. where it comes with M1 plus M2 plus M3. Then the only force that I have is just F, that is pulling them. Okay, F that is pulling them. So now I have, okay, now I'm joining 3 of them together. So the W is no longer W for one of them, but this is W 1 plus 2 plus 3. So the normal force is also N 1 plus 2 plus 3. Okay, and then the force that acting on this super large object is just the external force F. Okay, so now you ignore all of the tension because now you treat them as part of the object. You treat it as one large object. Okay, so string is our object right now. Okay, we assume there's no force in them anymore. So what am I going to do next? So again, I have A going to the left. All right, I have A going to the left. Okay, now questions 1 asks us to calculate acceleration. Okay, which means the equations that we're going to apply in this question is the summations F equals to MA, the second law. Okay, the second law. And then this MA, the accelerations is occurring along all the X component. Therefore, the force that I'm going to look at is just the force along X component. Okay, just the force along X component, because this is the force that is parallel to the acceleration. So we can only use them to solve the accelerations, to calculate accelerations. Now, if you want to calculate the equations, so the values, okay, so you want to calculate acceleration, MA, you need the known value for the left-hand side. So this is M, A. So left-hand side, you need a known value. Why? Because now your A is unknown. Okay, A adalah unknown, but also the rest of the terms, the rest of the variable, they must be known value. If you look at M1, along X component, you have one unknown. So you cannot use M1 to solve questions A because you don't have the values of T1. How about second object? Well, it's even worse. T1 and T2, you don't have any of them. So you cannot use it to determine A. Okay, because A is an unknown. We need a known value on the left-hand side. So M3, now M3, you have only one force, T2, but this T2 is an unknown, so we cannot use it. So look at the fourth diagram. Okay, now fourth diagram, I have only one variables along the x-axis, which is F. And yes, now this F is a known value, which means in order to solve questions A, this is the free body diagram that we are going to use. Okay, this is a free body diagram that we're going to use. So I want to modify my equations a little bit. So rather than MA, what am I going to do now? I'm going to write this as M1 plus 2 plus 3A. So this would be my F. Okay, so this is coming from the fourth diagram. So from here, you can then expand it. So according to the questions, now your F is equals to 1000 Newton, which is equals to M, okay, you want the total mass of all 3 of them. So you have a 3 kg plus 15 kg. Make sure the unit is in terms of kg plus 30 kg times with A. Therefore, A is then equals to 20.8 M as -2. So this is the answer for questions A. Okay, so this is the answer for questions A. And this is how we solve the questions. You try to identify, based on 4 diagram, okay, which diagram can be used to solve this question. So obviously, it's my fourth diagram because I have only one variables, one values along the x-axis, and we have the values of it. Okay, we have the values of it. So usually when it comes to these types of questions, okay, when it comes to when it comes to accelerations, quite often we use fourth diagram. Okay, agak kerap kita guna diagram keempat. Okay, because this one usually you will have the value for F, the external force. Usually, not always, yeah. Remember the terms that I use, usually we use the fourth free body diagrams to solve it. Okay, and then next question asks us to determine what? It asks us to determine T1 and T2. Okay, so T1, which free body diagram should be used? Obviously, the first one. Okay, why the first free body diagram? Because if you look at the first free body diagram, I have variables f. The only unknown is T1. So now I have A. Again, I can apply the same equations. So summations f equals to M1A. Okay, so according to the free body diagram, now my acceleration is going to the left-hand side. So I'm going to take left-hand side as positive, right-hand side as negative. So F minus T1 is equals to M1A. Okay, so I have F equals to 1000 minus unknown T1 equals to M1, which is a 3 kg. A, now I have it already, which is 20.8. Okay, so I can use 20.8. Why? Because now all of them, okay, object 1, object 2, object 3, or the super large M1, M2 plus M3, 4 of them, they are moving toward left-hand side with the same acceleration. Okay, because you pull them with one force and all of them, they move together. So rearrange the equation. I can then obtain T1 equals to 937.6 Newton. Okay, 937.6 Newton. So next, what am I going to do? I want to calculate T2. So now basically you can use any of them to determine T2. All right, so now you have what? Okay, you have T1s already. So you want to calculate T2 if you want to use the second diagram. You can also use a third diagram where you have only one T2 in the equations in the free body diagram. Would make it much easier for you. Okay, so let's use M3. So summations F equals to M3A. In my third free body diagram, I have only one tension, okay, and it's heading to the left. So now we are taking left as positive. So this T2, we are going to take it as a positive vector. Oops, sorry. So T2 is a positive vector minus, sorry, this is M2, yeah. No, the M3. Okay, this is M3, sorry. So M3, okay, so T2 equals to M3A. So the subscript, you have to be careful. Okay, jangan tertulis M2A. So T2 is the things that you want to calculate. And then M3, I have 30 kg. A is 20.8. 20.6. 20.8. Okay. 20.8. Therefore, from here, straight away, you obtain T2 is equals to 624.0 Newton. Okay, 624.0 Newton. So that is the answer. Of course, if you want to use the second free body diagram, go ahead. Okay, nothing's wrong. You have more than one method to solve this question. Okay, kamu boleh bermula dengan T2 dulu and then guna second free body diagram, cari T1 pun boleh. Kamu nak guna T1 and then guna M2 untuk cari T2 pun boleh, tak ada masalah. Okay, it's up to you. You want to solve which one first? You want to use which free body diagram? All of them, they are correct. Okay, in physics, we don't have a definite answer. Janji kamu punya jawapan make sense, then boleh dah, kira betul. Okay, tak ada masalah. So again, I give you 2 minutes to write it down. Okay, 2 minutes untuk tulis dia. So sekarang kita average ngam-ngam 15 minit satu soalan. So we can finish 8 questions within 2 hours. Okay, so anda catat dulu ya, anda catat. 2 minit bagi anda catat. Okay. Mana arrow saya? Okay. All right. So next, question number 7 is very similar to questions number 6. I will leave it to you. Okay, and then questions number 8, I will also leave it to you. It is a very simple questions, just that now it's in a vertical motions. And the key terms that you have to know now, because you have two objects, they are being connected by same string. Okay, which means both of them, M1 and M2, they have a same tension and they are moving with same acceleration but in the opposite direction. Okay, so you try it by yourself. If you don't know how to form free body diagram, you can go back to exercise 1. All right, you have a nice free body diagram in exercise 1 already for this question. So I'll leave it to you. I'm going to discuss questions 9 with you. Okay, questions 9 is a questions where one object is moving along the x component and the other one is moving along the y component. So now you have two objects A and B. They are being connected by a light string. A mass of 20 kg, it lies on the rough horizontal. So the keywords, now you see, they give you the terms rough surface. So rough surface means there's a frictional force. And again, this question is being very, very nice to you. Straight away, it gives you the values already. Okay, it gives you the values already. So now you have an object lies on the horizontal surface, the rough horizontal surface, and a mass MB is a mass of 4 kg. It's suspended in the air as shown in the diagram. So it's not touching the wall. All right, so it's not touching the wall. So B is released from rest. All right, now you release B from rest and both objects start to move. Okay, so how are we going to solve these questions? Again, as usual, we need a free body diagram. So for object A, okay, object A, the free body diagram, okay, start from a dot. So my object is now moving to the right-hand side. Okay, so let's see. How am I going to form this free body diagram? Object A is being pulled by a string. So there is a tension. So do I need to add any subscript? No, because I have only one string in this question. Okay, I have only one string in this question. And then now you place it on the rough surface. Object is moving to the right. Therefore, friction should be going to the left. Okay, so I have a frictional force that is going to the left. All right, and then object A is an object. Every object comes with weight. So I have W, A. Okay, and then object A, you place it on the surface, and it is the only object on the surface. Therefore, you have N that is going up. So done. That is a free body diagram for object A. So just to remember to put the accelerations outside the free body diagram so that you know which one is positive, which one is negative. All right. So let's look at object B. Object B is being hung by a string. So I have tensions going up. Okay, and then object B is an object. Obviously, it's come with weight. So WB going down. Now, if you look at the diagrams again, okay, now according to the diagram, it tells you A is going to the right. If A is going to the right, then what is the directions of motions of B? B will drops. So directions of A is going down. Put it outside your free body diagram. Okay, so now that I have a nice looking free body diagram, what am I going to do next? So if you look at questions A asks you to determine the accelerations. So if questions A asks you to determine accelerations, then you are going to focus on the axes that give you accelerations, the components that give you acceleration. So object A, the one that is related to acceleration, is X component. For object B, okay, object B, you don't even have to think. Why? Because you have only Y component. So this component. So now our task is to form an equation for these two components first. See if we have enough information to solve it. Okay. So if not enough, then you have to take into considerations the Y component for object A. kalau lah tak cukup maklumat. Okay, but our main focus right now is focus on the axis that is related to acceleration. Okay, that is moving with an acceleration. So object A, let's begin with x component. So summations f a x component is equals to ma. Okay, and this m is a mass of the object A. Along the x component, I have tensions and frictions, and my acceleration is going towards same direction as my tension. Therefore, I'm going to take right hand side as positive, left hand side as negative. Okay, so I have T minus F equals to MAA. So apparently you cannot solve these questions. Why? Because now you have two unknowns. All right, the first unknown is the tension. The second unknown is the acceleration. So let me simplify the equation first. T minus 4 equals to the mass, I think is 20. So 28. Okay, so this is our first equation that is coming with two unknowns. So two unknowns means you need two equations. First equation is coming from object A, so obviously second equations will be coming from object B. So let's do equations for object B. So summations FBY is equals to MBA. Okay, so object is dropping, so downward is positive, upward is negative. Therefore, I have WB minus tension equals to MBA. Okay, MBA. So W is mg, right? So mg, okay, mbg minus tension equals to MBA. So let me sub in the values that are given. So values given, B is 4 kg. So 4g, no, not 4g, sorry. 4 times 9.81 minus T equals to 4A. Okay, equals to 4A. So this is my second equation. Okay, this is my second equations. So now you look at two equations. You have two equations, equations 1 and equations 2. Each of them come with two unknowns. Therefore, you can solve it by using simultaneous equation. Okay, guna persamaan serentak untuk jawab dia. So if you use simultaneous equations, you will get A equals to 1.47 ms negative 2. So that is the answer for questions A. Okay, answer for questions A. So questions B, okay, if you solve it correctly, you're going to get T equals to 33.4 Newton. Okay, kalau kamu solve dengan betul, dengan berjaya, T is equals to 33.4 Newton. So that is how you solve it. Okay, sometimes you might not have enough information because sometimes questions won't give you friction. So if you don't have frictions, then what should you do? You need another equation. Okay, so remember, if you don't have friction, then what should you do? Now recall F is equals to mu n. Okay, then you are going to need the y component in order to find the values of n. So summations F A y is equals to 0 because there's no motions along x component. So n is equals to WA, which is equals to MAG. So ini biasanya yang kita buat if you are not given frictional force. Okay, that's why I say this question is being very nice to you. You don't have to calculate friction. Okay, so again, I give you 2 minutes to write it down and then 3 minutes is a break. Okay, so let us continue again at the 12 p.m. Okay, kita rehat sekejap, kamu catat ini and then rehat sekejap, nak pergi tandas, pergi, nak pergi minum, pergi. Kita sambung balik pada jam 12. Okay, so harap-harap anda okay kan semua setakat ini? Masih hidup tak?
Madam. Masih, Madam.
Okay, so seterusnya kita tengok questions 12. So questions 10, okay, is very similar to the questions that we just tried. Okay, as long as you got the free body diagram correct, then you should be able to get a correct answer. Okay, and then questions 11, very similar to questions 12. So I'm going to discuss a question 12 with you guys. So if you understand question 12, then you should be able to answer a questions 11. Right. So questions 12, the idea actually is very, very similar to the ones that we discussed just now, okay? The one with 3 strings. Okay. Let me draw a free body diagram first. Wait, yeah, I got an incoming message. All right. So this questions is very similar to the one that with a string between them just now. Okay, just that now you put them close to each other. So instead of tension, now what are we going to look at is the contact force, the reaction force between the object, because now they are touching each other. So which means these questions, we can also have a 4 forces acting on them, 4 free body diagram, sorry. 4 free body diagram from this diagram given. Okay, so let us begin with it. Wait, I think there's a typo in the questions. So it should be XYZ, okay? XYZ box, not ZYZ. So change the questions a bit. It should be X. Yeah, let me see. Can I change it? Ignore it. Okay, so I'm just going to change like this, easier. So this is X. Okay, so object X. Okay, object X. Now, what do I have? Okay, now this external force, I'm going to call it F. Okay, and if you look at the diagram, external force is in a direct contact with what? With my object X. Okay, it's contact directly with the object X, but not all the other object. So what am I going to do? Okay, I want to draw a free body diagram for each of them. Okay, I want to draw a free body diagram for each of them. So object X, this is my object. I have a force going to the right hand side, and then the force from object Y. Okay, so I want to write it as Fy. So when you push object X, it will push object Y. And at the same time, object Y will push backward. Okay, because of Newton's third law. Newton's third law say when you push an object, let's say this is a wall. Okay, I'm going to use the same example to make it easier for you. So when you push the wall with 10 Newton of force, okay, this 10 Newton is coming from you. Okay, just that you won't notice, but at the same time, the wall is pushing you back at a 10 Newton of force with the same amount of force. So this is what happens in the case, okay, where they're in contact with each other. So X push Y, and at the same time, Y is pushing X. Okay, so you have Fy that is going backwards. So you have a Wx, and then you have Nx. So this is for object X. So for object Y, okay, object Y. So what is the force that I have? So now the force that is pushing my object Y, okay, to the right hand side is coming from box X. It's not this F anymore. It has nothing to do with the external force anymore. The thing that is pushing my box Y is box X. Therefore, I have Fx. Okay? And at the same time, Y is pushing box Z. Y taller Z. So which means Z will push Y back with the same magnitude of force, same amount of force. So now you have an Fz going backwards. Okay, and then an Ny, sorry, and Wy. Okay, and then the next one, go back to object Z. So object Z, okay, what am I having now? Z is being pushed by Y. Okay, so it's being pushed by Y, so I have just Fy. So here I have Wz, and then I have a normal force for Z. That's it. Okay, that is a complete free body diagram for object Z. And then another situation is where I can treat them as one object. Okay, so now the last free body diagram, I'm going to do it as, okay, I'm going to do it as a object X plus Y plus Z. Okay, so now you have an external force that is pushing them. So this is the only force that I have right now. Because now I combine three of them, I treat it as one giant object. All right. So the weight is now the combinations of the weight of three of them is no longer just one. Okay, yeah, hang sikit dah saya punya PC. Okay, so now I have W, X plus Y plus Z. And then the normal force is also for X plus Y plus Z. So now I have all four free body diagram with all of them moving to the right hand side. So A is going to the right hand side for all four of them. Okay, so questions 1 asks you to calculate the accelerations of the tube. So you have 3 identical cubes. Now what does it mean by identical? Identical means all of them, they have the same shape and they have the same mass. So now your Mx, My, and Mz, they are all equal to 2 kg. Okay, at rest in a straight line on a smooth surface. So smooth means no frictional force. Okay, and they are in contact with each other. So a force of 12 Newton. So this 12 Newton is your external force. X on cube X. Okay, that's why I just put it in a free body diagram for object X. So determines the accelerations of cube. Now you want to determine accelerations. Again, you need a known value along the X component. Object X obviously cannot because you have an unknown. Okay, you have an unknown Fy. Object Y is even worse because both of them, they are unknown. You cannot use it to find A. Object Z, you have Fy, which is unknown, cannot. So the only remaining free body diagram that can be used to solve object questions A is object X plus Y plus Z, the combinations of 3 of them. So again, free body diagram number 4 is the diagram that we use to determine acceleration. So remember, that's why I told you, usually we use the combinations of all 3 boxes to determine the acceleration. So summations F equals to summations Fx for object number 4, so free body diagram number 4. So M, X plus Y plus Z. Okay, and then times A. So the force that I have is now equals to 12 Newton. So 12 Newton equals to 2 plus 2 plus 2, because 3 of them, they are identical. All of them, they have a 2 kg each. So times A. Therefore, my acceleration is equals to 2, 0, ms negative 2. So, okay, by right, it should be, you should mention the direction. Okay, I forgot about that just now. Because the acceleration is a vector. So you need to mention the direction. So 2 meters per second to the right. Okay, to the right. All right, now let's look at questions B. Questions B is asking for, so questions B is actually a very tricky questions. It's asking for resultant force. It's not asking for what? It's not asking for the reaction force. Dia tak minta kamu cari fx, dia tak minta kamu cari fy, dia tak minta kamu cari fz. The thing that it is asking, okay, I nak tukar sikit benda. Okay, I shouldn't use x because I have object x. Nanti kita keliru. Okay, so the thing that it is asking is the resultant force on X, the resultant force on Y, and the resultant force on Z. Okay, it is not asking for the reaction force. So kamu kena berhati-hati. Reaction force, dia merujuk kepada Fy di sini, Fz, Fx, Fy. This is the reaction force between object. But now it's asking for resultant force. So resultant force actually is very, very simple. Okay, so that's why I say it is a tricky question. You want to calculate resultant force for X, then you just use mxa. You don't even have to expand the equation. So mx is 2 kg, A is 2 meter per second, therefore it's 4 Newton. That is the resultant force acting on X. Resultant force acting on Y, object Y. So mya. Again, Y is 2, A is 2, again is 4 Newton. Okay, again is 4 Newton. Summations Fz, resultant force acting on Z. So mza, which is then equals to 2 times 2 again, which is equals to 4 Newton. So this is a very, very tricky question. Well, it is not asking for a difficult information, but it is asking for a resultant force. While resultant force straight away can be calculated by using MA. Okay, so dia tricky punya tempat di sini. Okay, dia nak tipu anda. So if you don't understand the question, then what students they always did in the exam, they go and find fx, fy, and fz, in which is wrong. Okay, because now there's not things that you want. The things that you want is just resultant, the total force acting on each component. Okay, the total force acting on each component. Okay, now question C. The force acting on Y, so now our object is Y, okay, object Y, because the question tells you now you want to look at what happened on Y, okay, what happens on Y. Okay, so the force acting on Y due to pushing by Z, okay, due to pushings by Z, by X. So what do you want right now? Let's see. The force acting on Y because of the pushing by Z. Question is asking for Fx. Okay, question is asking for Fx. But then we don't have enough information by just looking at object Y, right? Okay, but one thing that we do know, according to the diagram given, okay, according to the diagrams given, at this point, okay, at the point that is joining X and Y together, if object X is pushing the box with Fx, then at the same time it's being pushed back by Fy, the same magnitude but opposite direction. So in which it means if you cannot solve it by using second free body diagram, then you can solve it by using first free body diagram. Why? Because Fx is actually equals to negative Fy. Okay, Fx is equals to negative Fy. So now you want to find Fx, but you cannot use the second free body diagram. So what you can do, you use the first free body diagram. So object X, the free body diagram for object X. Okay, what do we have? We have F going to the here, and X, Wx, and this is our Fy. All right. So now what am I going to do? I want to expand the equation. So I know summations Fx is equals to mxa. Okay, so I want to expand the equations now. F minus Fy equals to, well, just now I calculate, I got 4 Newton, so 4. Okay, so given F is 12. So 12 minus Fy equals to 4. Therefore, Fy is equals to 8. Okay, so the magnitude Fy is equals to the magnitude of Fx. Therefore, Fx is also equals to 8 Newton. So the force acting on object Y due to pushings by X is 8 Newton. Okay, it is 8 Newton. So that's it. Okay, that's it. That is how you answer the question. So, well, of course, force, you need to mention its direction. So now it's to the right. Okay, based on the diagram, the force that is pushing on the object Y, okay, our Fx, if you look at the diagram, is going to the right. Okay, so again, I give you 2 minutes to write it down. Okay, this question is slightly tricky. Kita kata dia lebih tricky sebab dia tanya benda yang jarang ditanya oleh orang. Right? Okay, make sure to ask ya if there's anything that you don't understand sebab soalan ini dia tricky sedikit. Okay, so we are almost done. I think just got 2 more questions if I'm not mistaken. Okay, so next questions. Let's see what is the questions that I picked. Okay, questions number 13. Okay, soalan ke-13. A block accelerates 3.1 meter per second square down a plane. So you are given some informations where you have A going down, which is equals to 3.1 ms negative 2, and then the plane is inclined at a 30 degree, given 30 degrees here. So accelerations of gravity is 9.81 ms negative 2. Now this one usually in the questions in the exam they won't mention it. You yourself have to know the value G is equals to 9.81. So what is the coefficient of friction? Now what does it mean by coefficient of friction? If you recall, it is mu, okay, between the block and the inclined plane. So question asking for informations about friction. Okay, it tells you want to calculate coefficients of a friction. So even though questions didn't mention anything about frictional force, you yourself should know that there is a frictional force in this question because of this term, coefficient of friction. Okay, so remember the things that I told you before. Always ask yourself, does the question mention the rough surface or not? Or does it ask you to or give you the values of coefficients of friction? And these are the informations that tells you, that give you the hints. Okay, there's a frictional force in the questions. So let's start with a free body diagram. Okay, let's start from a free body diagram. So now I have a object, okay, and then this object is experiencing what? Okay, it's experiencing frictional force. So I have a frictional force that is going to work this direction. So F, and then what else do I have? Now this object, well, you call it object. Every object comes with weight. Okay, so I have a weight here, and then you place it on a surface. So it has a normal force, okay, and the normal force is forming perpendicular to the frictional force. All right, this is perpendicular to the frictional force. Okay, I think that's it. That is our free body diagram. Okay, so even though object is sliding down, it doesn't mean that there is a force that is heading downwards. No. Okay, so the things that we have, okay, let me put in the diagram so that you can see it nicely. So I have a normal force that is going up, and then I have a W that is going down, and then I have a F that is going backwards. Okay, so if you want to sketch free body diagram, basically you just transfer this diagram out from the diagram. Okay, free body diagram ini kamu pindah dia keluar, then it is a nice looking free body diagram. Okay, and then one more thing is missing in my free body diagram, which is the angle. You are given 30 degree. Then you need to know where is this 30 degree. All right, so if you're given this 30 degree, it represents the angles beside y-axis. Okay, it represents the angle beside y-axis. So therefore, I need to include the angles here. So this is 30 degree. All right, so this is our free body diagram. Now in calculations, we can rotate this free body diagram. How to rotate? By assuming this inclined surface is your x component, and then the surface that is perpendicular to the inclined surface is your y component. Okay, so basically you can put it as F going to the left-hand side, normal force going up, and then, okay, wait, yeah. And then your weight is going to work this direction. Okay, with an angle 30 degree beside y component. So this is what you can do in a calculation. Okay, so this diagram can be used in calculation. So in exam, if the questions ask you to do free body diagram, you use the diagram on the left-hand side. If you want to do calculations, then you use the diagram on the right-hand side. Okay, of course you can show both. Okay, one for the free body diagram questions, and then you resketch it for calculation. Okay, calculations, kamu tak payah tunjuk free body diagram tak apa, tapi kalau soalan minta free body diagram, kamu kena tunjuk yang merah punya dulu. Okay, because that is what happens in your questions. That is what happens in your diagram. So calculations, you can then rotate it a little bit. So why I want to rotate it? Because to make the calculations become easier. Otherwise, you need to resolve N, you need to resolve a F. Okay, then the situations will become very complicated. And you also need to resolve what? You need to resolve the acceleration. Okay, because acceleration is in the directions of the X component. Okay, so kalau kamu guna free body diagram dalam warna merah, kamu kena resolve friction, kamu kena resolve normal force, dan kamu kena resolve juga acceleration. Okay, sebab sekarang acceleration dia letak di line yang parallel to friction. Okay, so if you rotate the plane, okay, the free body diagram, then what will we have? We will have acceleration that is parallel to the x-axis. Okay, so it will make the calculation so much easier. Kalau kamu tak rotate, banyak benda yang kamu kena resolve. Okay, oops. So kalau kamu pilih inclined surface at x-axis, then the calculations will become very simple. Now, some students, they ask me, if I don't want to use an inclined surface as my x component, can or cannot? Yes, you can. Okay, but like I told you, you need to resolve a lot of things in that case. So the reasons why we choose an inclined surface as our x component is to make our calculations become easier. Okay, in exam, actually, it's totally up to you. You want to select which side as your x component, which part as your x component and y component. Okay, it's totally up to you. Okay, just that we will try to find the x component that will make the calculations become easier for us. Okay, not make it hard for us. Okay, so kamu lah orang yang tentukan di mana paksi x dengan paksi y Anda. Okay, bukan kami yang tentukan. Kamu sendiri pilih. Okay, so for example, if you want to choose here as the x-axis, boleh tak? Boleh, tak ada masalah. Go ahead. Cuma benar, kamu kena resolve banyak. Okay, kena resolve punya benar, dia je banyak. Kalau kamu guna free body diagram dalam hijau, then the only force that you need to resolve is the weight. Okay, if you use the one in red color, you need to resolve friction, you need to resolve normal, you need to resolve acceleration in your calculation. So everything becomes so much complicated. Okay, so inilah tujuan kenapa saya beritahu kamu pilih inclined surface as your x component. Alright, now that I have the free body diagram, what can I do? I'm going to form equations. Okay, so a question asks me to determine what? Okay, if you look at the question, it asks you to determine the coefficients of friction. So in order to calculate the coefficients of frictions, obviously we need the normal force and we also need frictional force. So it means that we need to do an equation for both x and y component. Okay, let's begin with x component. So summations fx equals to, now, x component we have acceleration, therefore ma. Okay, so for our x component, what do we have? We have just a frictional force. And if you look at these equations, the frictional force are not just frictional force. And we also have a w. Okay, you resolve w, wx, and you resolve w, wy. So along these x components, now you have two forces. You're going to put two of them. So wx minus f equals to ma. So ma. So wx, I can then expand it into mg. Okay, minus now frictions. I need to expand it. Why? Because now the question is asking for coefficient of friction, which is mu. So mg equals to mu and equals to ma. Okay, so the reasons why I expand it, because I need this mu. Okay, that is what the questions want. All right, so this would be my first equations. Second equations will come from y component. So since there's no motions along y component, therefore summations f equals to 0. Right? So according to my diagram, n minus wy equals to 0, and n is equals to, oh sorry, I missed something just now. Okay, bukan sahaja mg, it should be mg sine 30 degree. Okay, so my n is now mg cos 30 degree. So the reasons why I use cos for the y component, because angle is beside y component. So this is my second equation. Okay, this is my second equations. So what am I going to do next? Of course, you can calculate it. So let's see what is the information that we have. So you're not given the mass, right? You got too many unknowns. So what can you do? Okay, let's sub 2 into 1. Okay, sebab kita tak ada mass. Actually, kita tak dapat kira lagi. But then what you can do, you sub 2 into 1. Then you have a mg sine 30 degree minus mu mg cos 30 degree equals to ma. Now all three of them, they come with m. So I can cancel it out. Okay, I can cancel it out. So remaining terms, I have g, which is 9.81. So 9.81 sine 30 degree minus mu, okay, minus mu 9.81 cos 30 degree equals to acceleration, which is 3.1. So rearrange equations, you obtain mu, which is equals to 0.212. Now remember, okay, mu is a dimensionless quantity. Okay, dimensionless quantity means that it don't have unit. So you don't go and add any unit for it. If you put a Newton there, then 1 mark will be deducted. Okay, 1 markah akan ditolak sekiranya Anda letak unit untuk jawapan akhir. Alright, so this is how you solve it. Okay, this is how you solve it. So when it involves a coefficients of a friction, usually you will need normal force. Okay, biasanya kalau dia sebut berkenaan pasal coefficients of friction, Okay, iaitu mu bermaksud Anda akan perlukan N dengan F. Okay, dia datang dalam pasangan. Okay, dia datang dalam pasangan. So make sure you always know how to use equations F equals to mu N. Okay, so when you have N and F, so usually one of them, they are coming from y-axis, and then the other one is coming from the x-axis. So you need two equations. Okay, you need two equations. All right, so again, I give you 2 minutes to write it down. Then I will proceed to the last question. Okay, 2 minit bagi Anda catat.
Madam, I have a question. So when there is
Yes.
a mu, so you always relate with the normal force, the normal reaction force in the... Okay.
Yes.
Okay.
Okay, so class tutorial kita akan fokus more on technique in answering subjective questions. So if you have anything you don't understand, make sure to ask. It's very, very important. Okay. All right, so questions 14. Okay, questions 14, that is your job. Okay, I want you to submit the answer for these questions before, your lab report is before 5 p.m., right? I give you until 10 p.m. tonight. Okay, so before 10 p.m. tonight, I want you to complete just this one questions. If you can answer it correctly, means you understand chapter 4. Okay, that's why I keep it as your homework. So I will create an assignment in your Google Classroom after this. Once you're done, you submit the answer in a Google Classroom. Okay, as a proof of attendance juga kita kata. So just one questions, okay? I don't ask for more. I just ask for this one questions. I want you to try it. I want to see, okay, how to answer these questions. I want to see a nice, clear, free body diagram for each object. And then I want to see, okay, which one you apply first law, which part you apply second law. Okay, and then after that, you just solve it. Okay, so the conditions, the things that you must have is which law you're using, and then the free body diagram is a must. I want to see free body diagram, right? So questions 14 is your works. Next, I'm going to discuss questions 15. So questions 15 and question 16, they are very similar. Question 16, you have the free body diagram and the equations already in your exercise 1. So I leave it to you. Now I want to go through question 15 with you. So once we are done, then that is the end of today's class. And also that marks the end of chapter 4. So questions 15. A man of a 60 kg, now you have a man of 60 kg, is standing inside a lift on a weighing scale. Aha, now you have weighting scale. So this is a very tricky questions. You always have to remember, weighting scale, it gives you the readings of normal force, not weight. Okay, biasanya pelajar salah because they don't understand what does it mean by, what is the readings given by weighting scale. Weighting scale always give you normal force, not weight. All right. So standing on a weighting scale, calculate the readings of the weighting scale while the lift is moving up with a constant acceleration of 2 meters per second. So now you have a lift, okay, and then the person is standing in a lift on a weighting scale. So now it's going up with A equals to 2ms negative 2. So now, according to the questions, my object is the man, okay, it's a human, not the lift, the whole thing. Okay, so what am I going to do? I want to sketch a free body diagram for this object. So this is my object. This is human. So object is a man, and then this man's come with a weight, which is W. And standing on the weighting scale, so you have a normal force, and according to the question, the lift move upwards. So you have A going up. So this is the complete free body diagram for the man. So based on this free body diagram, I then form an equations by using Newton's second law. So summations F equals to MA. Object going up, so I take upward as positive, downward as negative. So N minus W equals to MA. Okay, the readings that I want is a normal because the readings on weighting scale. So N equals to MA plus W is mg. Okay, it's mg. Therefore, it is equals to 60, and then A is the 2 plus 69.81. Right? So you sub everything into, you put everything into your calculator, straight away you got the readings on the weighting scale, which is a 708.6 Newton. Okay, so you need to rewrite it as the readings of the weighting scale is 708.6 Newton. All right. So from the calculation, this question, the things that you need to know is what is the reading that can be obtained from weighting scale. The reading is normal force. Okay, that's why I calculate normal force. So biasanya pelajar salah soalan ini sebab apa? Sebab dia terus pergi kira W. Alright, so W, it give you weight. Okay, so even though the name called weight, but it doesn't give you the reading on the weighting scale. Alright, so jangan tertipu. Okay, so kamu kena faham alat apa bagi kamu reading apa. So that is questions 15. Okay, questions 15, the things that I want to stress is just the reading on the weighting scale. So questions 15 done. Question 16, I will leave it to you. The free body diagram, the equations and everything is in your exercise 1 already. Okay, you can refer to exercise 1 and then complete it by yourself. So of course now if you have any questions, you can post in the group. Okay, we discuss together as a class. Don't PM the P. If you PM the P, then it just becomes you and me. The rest of them, they won't learn. Okay, maybe they also don't know, or maybe they also PM the same question. All right. So if you got any questions, okay, from questions 1 until question 16, if there's anything that you don't understand, that you cannot answer, you ask in the group. We solve it together as a class. All right. So tak jumpa classmate, takkan tak nak cakap dengan classmate kan? So kita cuba guna group kita. Okay, supaya anda dapat cakap dengan kawan anda, dapat communicate dengan kawan anda. Okay, so at least Sem 2 when you enters college, you won't feel macam mana kata, kamu tak rasa macam pelik. Okay, so try to use a group. Okay, try to communicate with your friends. All right, so I think that marks the end of today's class. If you have any questions, you may ask. If no, then you may leave the class now. Okay, thank you for attending the class. So next week, Monday, the first 2 hours, we will use it for tutorial chapter 5. All right, and then the second 2 hours, we are going to use it for lab. Okay, so that's all for today. You may leave the class.